So hello, in this video we are discussing the problem that is swap column and find a path. So in this column we have given two rows and n columns. So I draw for you two rows and n columns like that, and in this question we can do operation any number of time. So the operation is you can swap any two columns in this matrix, and after that doing all operation you can find the maximum pass sum of it, and for the maximum pass sum you can only move to the right direction, that is I plus 1 comma j, and to the down direction, that is I comma j plus 1. So the constraints are n till 500 and uh, aij from minus 10 to the power 5 to 10 to the power 5. So let's look on the test case. So the first test case only have one column, so no need to do operation. The second test case have uh, three columns, so we swap the column 1 and 2 and then 2 and 3. And after we will get we will calculate the maximum pass sum. So the maximum pass sum of it path sum of it MPS, it will be greater than the original matrix. Also, if you calculate its maximum pass sum, so it is around 23 or I guess 24. And if you find after swapping the columns, if you find the maximum pass sum of this, you will get 29. That is plus 5, I guess, or you get increment. So the approach of this problem. So my approach is to the problem is like that we we want to maximize the sum. So when you are traveling the first row, or when you are traveling the first row, you want to take the maximum element from it, because when you are traveling it means the first row, and when you go to the down, take the down step, you cannot move to the upward step. Upward means you cannot, when you move to down, you cannot go to the uh, to the to the top. That is there is no option to go to the top. You can only move to right, that is right and down direction. So you can only once move to the down direction. So for that, uh, moving to the down direction, you want to take the maximum elements from the first row, that first row, before going to down, and after going to down, you also want to take the maximum element from the second row. As let's take example 5 8 5 8 2 8 5 3 1 10 3. So consider the first row as AI and second row as BI. So my approach to the problem is that uh, we want the maximum pass sum. So for the first row, we want to choose the maximum element to travel. So what we need to choose? So we will choose for the first row, that is AI. Let's consider first row as AI and second row as BI. So where AI is greater than BI, so we will choose that index. So here is 2. We will choose 2. Here we will choose 5. So for that we will write it in the front, in the starting 2 and 5, because in this case this is optimal to take. We want the maximum pass sum, so we want to take the maximum elements. So for that we will take the maximum of AI and BI, that is AI. So we will take the AI that is greater than BI, and here also AI is greater than BI, and for similar for BI. After that we will take the BI that is greater than AI, that is 10 4, and we will write the element as it is. So we can travel like this uh, uh, till the second index in this in the AI, and after for the down step we can uh, travel from the third index. So we can take 2 5 uh, 10 plus 4, so we can travel like that 2 5, and we will take 8 here. You can also take here 3, means here 4 and here 3, but we want the maximum pass sum. That's why we take here 8, because 8 contributes more in this scenario. If you go through this way, so you will get 2 plus 5 plus 3 plus 4 plus 10, that is lesser than this stuff. So when we have uh, some AI greater than BI and BI greater than AI, so we will simply add those AI to our answer and those BI to the answer, and after that we will add the maximum element that is not part of uh, AI greater than BI in in the ARA, in the first row. Once we consider first row as ARA, so in the ARA, that is here is the maximum element that is not greater than that is not AI greater than BI is 8. So we will take that maximum element. Let's consider the another case where all elements are AI greater than BI. So you can see all elements are greater than means ARA elements are greater than BRA elements. So here in this scenario you can take all these elements, the sum of all these elements, and take the maximum one, because uh, in this scenario we will travel like straight, and on the one time we are moving to the down, that is the 2 comma n index. So we want the maximum element here to maximize the MPS, that is maximum pass sum. So we will choose the 4. See in a similar case for this. Uh, so when we have BI greater than AI for all, so we will take all these elements, but at the starting point when we start, we want the maximum element to start here. So we can arrange it like 5 4 3 4 2 3 1 2, and we can travel like this. So I think you understand the concept concept and the logic of it. So let's look on the code. So in the code I take two vectors, that is AI the first row, and BRA, that is vector B, vector A and vector B. So vector B as the second row. So here I declare two vectors, great and small. So the element that is greater than equal to bi, I push back the index of that such elements in the great array, and uh, that are the element that is bi greater than I push the index of that such elements in a small array. Here I calculate the maximum of A and maximum of B when the greater dot size is equal to 0, means the all elements is first case where the all elements are greater than bi. So simply we what we do, we take the sum of whole array, sum of A plus the maximum of B. So similarly, we also do here that stuff, that is we take the sum of sorry, it is the second case where all elements means greater dot I is 0, means there are no elements of ai greater than bi, means there is all elements of bi greater than ai, the meaning of it. So for that case we take the sum of b plus the maximum element of a. So So we did it sum of b plus maximum element of a. And similarly, if a small that is bi greater than ai are not possible, then we will take the sum of a vector and the maximum of maximum and plus add the maximum of b vector, like this. That is the case. We take the sum of a vector and add the maximum of b vector. And for the third case, we have some ai greater than bi and bi greater than ai. So for that case, we will add all the ai greater than bi and greater than bi to the sum, that is our answer, and also bi greater than ai to the sum, that is our answer. So here also we did it. The number that is greater than bi, we add it those 2 5, and we also add 2 10 4, and we will take the maximum of the remaining element that is not mm, greater than bi. You can also skip this step I, that is taking the maximum of bi. You only need the maximum of ai that is not equal to, not in the greater vector, sorry. So you can use a map to uh, map or map the element that we did not take in the greater array. So uh, we will map the elements in the greater array. There are, we will take the indices. So we will map that uh, suppose we we take the index 0 in greater array, then we put mp of 0 as 1, and mp of 0 as 1. So here we are checking, just checking that the where the mp of I, the index mp of index is not equal to 1, we will taking it as taking the maximum of it, and after that doing all that stuff, we will add the maximum element, a maximum element that we find here to the sum, that is our answer, and finally we output our answer. So try to run it. This is the code, and it is running fine. So if you guys understand the video then like the video, and also comment down which question you do not understand. I will try to make the video on that question. So thank you for watching this video. Take care. Bye.